when we talk about Hess's law, right? What do you mean by Hess's law, right? Hess's law will be very useful to know the enthalpy change of a chemical reaction, which is very difficult to find, right? Is it clear? Hess's law will
Yeah.
be very useful to find out the enthalpy change of any chemical reaction, which is difficult to find out, right? So Hess's law is for those where enthalpy change of a reaction is difficult to find. Suppose this reaction, right? Is it possible in the lab, right? Is it possible in the lab that you are mixing carbon and hydrogen and we're getting an alkane? It's not possible, right?
No.
Right?
Yeah.
Comfortably, it's not possible, right? So can we because if this was possible, then we would have made petrol, diesel, right? And there wouldn't be any
Yeah.
wars going on shortage of petrol and all, right? So this is very
Mm-hmm.
important that if you see that whenever we are seeing this reaction, can we find out the enthalpy change of the reaction? Yes. What we do, we can make a Hess's law triangle, right? We have to join
Yeah.
this and this by a closed energy cycle, right? We know that if we can take carbon and hydrogen, we can combust it, right? Hess? And we can get
Mm-hmm.
carbon dioxide plus H2, right? We can get this
Yes.
carbon dioxide plus H2. So this reaction enthalpy change we can find out, right? Isn't it? We can
Yeah.
also combust a alkane and find it by enthalpy of combustion. We can get carbon dioxide plus water. We can get the enthalpy change of this reaction, can't we? We can get, right? Is it clear to you, right?
Yeah.
So that's a very important part we have to master, right? We can find out these, right? So what is Hess's law? Hess's law says that the enthalpy change of any chemical reaction, now I'm going from here to here, is independent of the path taken, right? You can go in this direction also, right? Clear to you? Is independent of the path
Yeah.
taken, right? Is it clear to provided the starting and the and that final condition are
Ending.
the same? Is it clear to you, right? Do you get my point, right?
Yeah.
Understood. We can go via the blue path. The same enthalpy change will be going by this path also, right? Now we have to know
Mm-hmm.
that we have to make sure that delta H1 is equal to what? Delta H1 is equal to, tell me, delta
Delta
H3.
H1 is equal
Delta
to, okay.
H3, see the arrowhead you match? H3. Understood. And what happens? This arrowhead is opposite. Can you see this? So we have to flip
Yeah.
this. When flipping this, what happens? Tell me. The sign flips only, right? The enthalpy sign flips. Is it clear to you?
Yeah.
When you are flipping a reaction, what happens? Please tell me. When you're flipping a reaction, the sign of the enthalpy
The
change.
sign,
Is it clear?
it
Do you get my
flips it.
point? So we can
Yes.
find out delta H3 by enthalpy of combustion in a calorimeter. We can find out H2. See, we can find out the unknown enthalpy change of a reaction, right? This is the Hess's law.
Mhm.
What is Hess's law? Hess's law says that the enthalpy change of any chemical reaction is independent of the path taken, right? Isn't it? And
Yeah.
provided the starting conditions and the final conditions of the reactant and product are the same. Are you okay with this, right? Do you get my point over here? How to do this part? Got it?
Yeah.
So this is a very important portion we have to master, right? Now, moving to this part, we to know that if we see that when we talk about the Hess's law, right? We can apply Hess's law to this part, right? Now, if you see, suppose we are
Yeah.
taking a reaction like this, right? Fine, reaction like this, right? Understood this part, right?
Yeah.
Get my point? So
Mm-hmm.
this reaction is what? So this is the target equation, right? This is the target equation, and these are the supplied equations. Got it? Understood this part? Supplied
Yeah.
equations, right? Now, can you tell me that we have to match? We don't try to trace the common reactants over here, right? Understood? We don't trace oxygen, right?
Mm-hmm.
We don't trace oxygen. We don't trace oxygens. We don't. Any
Yeah.
common reactants in the supplied equation, we don't trace. See, where is sulfur dioxide in the target equation? Tell me. Right hand side. And how many
Yes.
moles? 1 mole. We have to match the moles also. Where is this sulfur dioxide in the supplied equation? Equation 1 or 2? Please tell me.
It is in, it is in two.
Equal to which side? Left hand side. So we have
Yes.
to flip this. We have to flip this sign also, isn't
Um.
it? Got it?
Yeah.
Now check the moles.
Yeah.
1 mole. This is 1 mole. Is it clear to you, right?
Yeah.
Now, if this was two, what would have been done? You flip it, and after that, tell me, you
You
divide
divide
the
it.
entire reaction by 2, divide this by 2 also after flipping, right? Clear?
Yeah.
So what we do,
I
we write
see.
down as it is. This reaction, sulfur trioxide gives you sulfur dioxide plus half oxygen. Done. Then where is
Yes.
sulfur on the target equation? Tell me. Right, left hand side.
Yes.
Where is sulfur on the supplied equation?
Left hand side.
Left hand side, isn't it? We don't do anything. We do it as it is, right? So delta H we have to
Yeah.
flip it, right? This delta
Mm-hmm.
H is we have to flip this plus 98. Now we have to take this as it is. So sulfur plus half, 1.5 oxygen, right? Gives you sulfur trioxide, right? So delta H is equal to minus 395, right? Is it clear? Now you
Yeah.
add up these two reactions. See, half oxygen gets cancelled, right? With half oxygen, right? Sulfur trioxide
Mm-hmm.
get cancelled. What you get? Sulfur plus 1 oxygen gives you sulfur dioxide, right? Clear?
Mm-hmm.
And you have to add up these, right? Clear?
Yeah.
395 minus 395 plus 98, right? You have to add up these, right? Clear? We're getting the enthalpy
Yes.
change, right? Clear? Okay, fine.
Mm-hmm.
So always need to do like this, right? For the enthalpy Hess's law question, right? So this was the. Can you quickly share the question paper? So this is a May 2025 question, right? Common question will be coming, right? Like this. Do you get my point?
Bug got it right
Understood.
now.
What you do, you have to make sure that you are. Wait. No. You show me how to work, right? Or you do. You
Yeah.
show me how to do work. You have to
Okay.
write down all the equations and then cancel out, right? Did you get my point? Please
Yes.
write down one by one. I'm just coming back. Just 1 minute. Amazing, right? So we trace, right? Isn't it? The elements which are
Yeah.
there. See the common elements you don't have to trace, right? See HF you have to trace. Wonderfully done, right? Fine. You divide it by two.
Mm-hmm.
Wonderfully, wonderfully, wonderfully done. Wonderfully good. Very good. So this was all about the Hess's law. This is the common paper, so you all can try this question, right? So this is always try to write down in this way as we have to make sure that we don't make any mistakes, right? Like this and add up this, right? And make this right. Thank you so much. So this was all about the Hess's law portion.